This is the confusion matrix. I see that it shows the model's predictions versus the actual iris species. Each row represents the actual species, Iris setosa, Iris versicolor, Iris virginica respectively, and each column represents the species the model predicted. For example, the top left 50 means the model correctly identified 50 Iris setosa samples. The 2 in the second row, third column means the model incorrectly predicted 2 Iris versicolor samples as Iris virginica. Pretty neat, huh? A confusion matrix is a table showing the results of a classification model. It visualizes how many instances of each class were correctly and incorrectly classified. Think of it as a summary of the model's performance. It helps us calculate other metrics like precision, recall, and accuracy. The main goal here is to evaluate how well a model classifies different iris species using sepal length and width. We use the confusion matrix to do so. We're going to determine how accurate the model's predictions are. Sounds fun? This is the core question. Awesome. We'll use the confusion matrix to check the truthfulness of several claims about the model's performance. I'll determine which statements correctly describe the model's precision, recall, and accuracy based on the data given in the confusion matrix. This statement claims that the model's precision for Iris setosa is 100%. Precision is calculated as true positives plus false positives. We will verify this statement using the given matrix. This statement checks if the recall for Iris versicolor is 100%. Recall, or sensitivity, is calculated as true positives plus false negatives. Again, let's look at the matrix and calculate to find out. This checks if the overall accuracy is greater than 98%. Accuracy equals true positives plus true negatives, total observations. We'll calculate the total accuracy using the given data. This statement asks if the recall, sensitivity, for Iris virginica is greater than the recall for Iris versicolor. I'll compute the recalls to check this claim. This line indicates that the detailed calculations for precision, recall, and accuracy are not explicitly displayed in this particular table. However, those calculations will be performed using the information available in the confusion matrix. Let's get calculating. I'm evaluating how well a model classifies different iris species. This involves looking at its performance metrics like precision, recall, and accuracy. We'll use a confusion matrix to achieve this. This table shows how many times the model correctly or incorrectly predicted each iris species. Each row represents the actual species, and each column represents what the model predicted. For example, the first row shows that the model correctly identified 50 Iris setosa samples. This is the actual confusion matrix. The numbers tell us the model's predictions. 50 Iris setosa correctly predicted, 48 Iris versicolor correctly predicted, and 49 Iris virginica correctly predicted. The remaining numbers show the misclassifications. I'll now evaluate the accuracy of each statement regarding the model's performance. I will need to use the values from the confusion matrix to compute metrics and validate the statements. Let's check this. Precision is the ratio of correctly predicted positive observations to the total predicted positive observations. For Iris setosa, all 50 were correctly predicted, and there were no false positives, incorrect predictions. Therefore, the precision is perfect, 100%. This statement is true. Recall, or sensitivity, is the ratio of correctly predicted positive observations to the total actual positive observations. For Iris versicolor, 48 out of 50 were correctly identified. That's 96%, not 100%. This statement is false. Accuracy is the ratio of correctly predicted observations to the total number of observations. The model correctly classified 147 out of 150 iris samples. That's 98% accuracy. This statement is true. Recall, or sensitivity, measures how well the model finds all positive cases. For Iris virginica, recall is 49/50ths, 98%, and for Iris versicolor, it's 48/50ths, 96%. Iris virginica has a higher sensitivity. This statement is true. This is the confusion matrix. I see 50 correctly classified Iris setosa, 48 correctly classified Iris versicolor, and 49 correctly classified Iris virginica. The other numbers show misclassifications. For example, 2 iris versicolor were incorrectly classified as iris virginica. This matrix helps me calculate the model's performance metrics. This statement checks if the model's iris setosa predictions are all correct. Precision is calculated as true positives divided by true positives plus false positives. For iris setosa, all 50 were correctly predicted, meaning there are no false positives, incorrectly predicting setosa when it's not. Hence, precision is 100%, or perfect. Awesome. This statement tests if the model identified all the iris versicolor. Recall is the ratio of true positives to true positives plus false negatives. I see 48 true positives and 2 false negatives, missing iris versicolor. Therefore, the recall isn't 100%, it's 96%. This means the model missed 2 iris versicolor samples. Accuracy tells me the overall correctness. I calculate accuracy by dividing the total correct predictions, 147, by the total number of samples, 150. This is 98%, which is above 98%. That's really good. Sensitivity is another term for recall. For iris virginica, recall is 98%. For iris versicolor, it's 96%. The statement is correct. Iris virginica has a slightly higher sensitivity. This is a table that summarizes the model's predictions. Each row represents the actual species, each column the predicted species. The numbers show how many instances fell into each combination of actual and predicted species. I use it to calculate precision, recall, and accuracy. This is what I'm doing. I'm evaluating how well the model classifies the 3 iris species. I will use the provided confusion matrix to understand the performance. This refers to the linear discriminant analysis model used for classification. LDA is a powerful technique for finding linear combinations of features that best separate different classes. I'm evaluating how well the model performed. I'll look at several metrics to assess its effectiveness. I'm asking you to identify which statements accurately describe the model's performance based on the provided information. Let's analyze each statement carefully. This is where things get interesting. This statement checks if the model correctly identified all instances of iris setosa among those it predicted to be iris setosa. We'll need to calculate the precision to verify this. Precision is calculated as true positives plus false positives. This statement checks if the model identified all actual iris versicolor instances. Recall is calculated as true positives plus false negatives. We'll verify this using the confusion matrix. This statement checks the overall correctness of the model across all species. Accuracy is calculated as total correct predictions, total observations. We'll calculate this to see if it's over 98%. This statement compares the model's ability to correctly identify iris virginica versus iris versicolor. Sensitivity is another name for recall. We need to calculate the recall for both species and compare them. I'm evaluating how well a linear discriminant analysis, LDA, model, a type of machine learning model, performs at classifying iris flowers. LDA uses linear combinations of features to create new features which maximize the separability between different classes. We'll check how accurate its predictions are using a confusion matrix. This matrix shows the results of the LDA model's predictions. Each number represents how many times the model predicted a specific iris species correctly or incorrectly. For example, the first row, 50, 0, 0, means that the model correctly predicted 50 iris setosa flowers. The other rows follow the same structure for iris versicolor and iris virginica. This is the actual confusion matrix. It's a 3x3 matrix. Each row represents the actual species, and each column represents the model's prediction. The diagonal entries show the correct predictions. For example, 50 iris setosa flowers were correctly classified, 48 iris versicolor, and 49 iris virginica. The off-diagonal entries represent incorrect classifications. Let's see what conclusions we can draw from this. Precision asks, of all the flowers the model predicted as iris setosa, what proportion were actually iris setosa? For iris setosa, The answer is 50 out of 50 predictions equals 100% perfect precision. Recall asks, of all the actual iris versicolor flowers, what proportion did the model correctly identify? The model correctly predicted 48 out of 50 iris versicolor. This is 96%, not 100%. Accuracy is the overall correctness. We got 50 plus 48 plus 49 correct predictions out of a total of 150 samples, which is 147 divided by 150 equals 98%. Therefore, this statement is correct. Sensitivity is another word for recall. For iris virginica, recall is 49 divided by 50 equals 98%. For iris versicolor, recall is 48 divided by 50 equals 96%. So, iris virginica has higher sensitivity. I'm evaluating how well a model classifies different iris species. I'm using a confusion matrix to do this. It's like a report card for the model's performance. This is a table that summarizes the model's predictions. Each cell shows how many times the model correctly or incorrectly predicted a particular species. For example, a value of 50 means that the model correctly predicted 50 instances of iris setosa. This refers to the actual species of each iris flower. It's the ground truth, the correct answer. This shows what species the model predicted for each iris. It's the model's guess. One of the 3 iris species I am classifying. Another one of the 3 iris species I am classifying. The third of the 3 iris species in this classification task. The model correctly identified 50 iris setosa samples. The model incorrectly identified 0 iris setosa samples as iris versicolor. The model incorrectly identified 0 iris setosa samples as iris virginica. The model incorrectly identified 0 iris versicolor samples as iris setosa. The model correctly identified 48 iris versicolor samples. The model incorrectly identified 2 iris versicolor samples as iris virginica. The model incorrectly identified 0 iris virginica samples as iris setosa. The model incorrectly identified 1 iris virginica samples as iris versicolor. The model correctly identified 49 iris virginica samples. This is the quiz question itself. It asks you to determine which statements about the model's accuracy are correct based on the provided confusion matrix. Statement A refers to the precision of the model for the iris setosa species. Precision measures how many of the model's iris setosa predictions were actually correct. Statement B refers to the recall of the model for iris versicolor. Recall measures how many of the actual iris versicolor samples the model correctly identified. Statement C refers to the overall accuracy of the model. Accuracy is the percentage of all samples that were correctly classified by the model. Statement D refers to the sensitivity, recall, of the model for iris virginica versus iris versicolor. This means I'm comparing how many of the actual iris virginica and iris versicolor samples were correctly identified by the model. This is the confusion matrix. I see that it's a 3 by 3 matrix. Each row represents the actual species of iris, and each column represents the species the model predicted. For example, the first row, 50, 0, 0, tells us that the model correctly identified 50 iris setosa samples. It made no mistakes for this species. I'm checking the precision for iris setosa. Precision is calculated as true positives divided by true positives plus false positives. For iris setosa, that's 50, 50 plus 0, equals 1, or 100%. Perfect precision. Let's examine iris versicolor's recall. Recall, or sensitivity, is true positives divided by true positives plus false negatives. For iris versicolor, that's 48, 48 plus 2, equals 0.96 or 96%. Not 100%. I'm calculating the overall accuracy next. Accuracy is total correct predictions, total observations. In this case, that's 50 plus 48 plus 49, 150 equals 147 150ths equals 0.98 or 98%. Yes, the accuracy is above 98%. Finally, let's compare the recall, sensitivity, for iris virginica and iris versicolor. For iris virginica, recall is 49, 49 plus 1. equals 0.98 or 98%. Iris versicolor's recall is 96%. So, yes, Iris virginica has higher sensitivity.